Well, the moment has come. You get to start seeing what the heck is this magic formula thing that we may have mentioned 17 times in class. The magic formula is beautiful, and this very first video is just going to be an introduction to what the heck does it do, and we're not going to be doing any math. In fact, I forbid you from doing any math. So as an example, we're going to use the friendly function y equals e to the x. Here it is. You're familiar with it and you're comfortable with it. Over here down in the lower right portion, you see what would happen if we had to build a tangent line to e to the x at x equals 0. And if we built that, and that's a very basic fundamental of calculus, if we built it, it would look like this. And we learned when we were doing tangent lines that a tangent line is a linear approximation of a curvy function that's pretty good in a very, very tiny neighborhood or region. But then, as you can tell, as you move much distance away from the center of attachment, which in this case is x equals 0, it ends up becoming a very bad approximation. So we're going to put this tangent line in the background, and we're going to move on to bigger and better things. E to the x is still the star of the show, but we're going to ignore the tangent line, and we're going to go through a series of other approximations. If I punch in y equals 1, well, that's a pretty lousy approximation. It hits at the same y-intercept, but that's about it. So let's get rid of it. Instead of y equals 1, why not y equals 1 plus x? Well, it's no coincidence, but maybe you think it's a coincidence. We're back at the tangent line, which is an okay approximation, good enough for when we were younger and we were AB calculus students. But now let's take that y equals 1 plus x, and let's add a third term, which is x squared over 2 factorial. I wonder where that came from. Whoa, look at this. We've got a curvy function, as you would expect y equals 1 plus x squared over 2 factorial would be. But if you look at this area, x equals 0, this curvy function is curving like e to the x. And just like a tangent line, it's pretty good for a neighborhood, and then it eventually starts being quite a bit different than e to the x. But you know what? For an approximation, that's probably better than the tangent line. Could we do better? Certainly. We're going to take that previous function and add a new term, x to the third over 3 factorial. I activate it. Holy cow. Look at that. This curvy function is starting to look a heck of a lot like e to the x. In fact, for quite a span, I'm just estimating here, maybe from x equals negative 1.5 over to x equals, looks like 2 maybe, you can barely tell the difference between those two. Well, if some is good, more is better. So let's add on, let's get this one out of there and add on a 4th degree term. Holy cow. Now, of course, way over here on the left, this is not a good approximation. But if I look over here, basically from x equals negative 2 to x equals 3, 2 to 3, it looks like a perfect approximation. It looks like there's almost no difference. So think of how far we've advanced as a society. When I look at y equals e to the x, last year during Calculus AB, you thought this straight line was a worthy approximation of e to the x. But what we're about to discover is this curvy line is a much, much, much better approximation of e to the x. Our problem is, how can we build that curvy line? We did learn how to build that tangent line following a procedure, so there's going to be a procedure that allows us to build this curvy line. That procedure is brought to you by the magic formula. Down here in the corner, if you look at that beautiful but possibly intimidating formula, that's how we're going to build this polynomial. And by the way, you might wonder, why would this be any good approximation for e to the x? One way to think about it is, back in the day, before all the technology we have, you might not be able to work with e to the x very well, just doing arithmetic, but even though it would take a long time, you could plug in x values and get out y values for this fourth degree polynomial just by arithmetic. Really everything in there is just multiplication and addition. So here's our deal. We're going to get to know the magic formula. As we get to know the magic formula, we're going to build these big polynomials, and there's going to be plenty of vocabulary to go with that. That's going to be called a Taylor polynomial approximation, and it's going to be a better approximation for a curvy function than what we used to have when we were young and naive. All right, that's the show. This is just an introduction to the magic formula. On the very next video, you're going to learn how to use it to build that approximation.